Welcome you all to this video. So this video is definitely going to help you find the remainder of any given exponential. So that is why we call this as your remainder theorem. It is a part of your number systems. You may also take as a part of your surds and indices. So somewhere where you will get your exponents and you're supposed to find the remainder. You can definitely make use of this video to find the answers. So there are different methods involved. So let's go into the video, get into the video to understand the concept better. The rules to find the remainder are as follows. So one is your basic rule. So we have the basic rule. We'll start from the basic rule. The basic rule also has 3 or 4 criteria. So accordingly we can learn through that. And then comes your common factor. So you have a common factor concept, Fermat's theorem and your Wilson's theorem. So the basic rules, probably as I told you, will take 2 or 3 types, and post which you have these 3 individual types to get the answers done. So let's go one by one. So the first basic rule is here. This most of you must have already known, but still it is better to go from the beginning. So I am just stating this basic rule as your first rule as such. So the remainder of x power y when you divide by d, any divisor d is nothing else but the remainder when you divide r to the power y by d, where r is the remainder when x is divided by d. That is, you divide this x by d, you find the remainder, and that remainder to the power y when you divide by d, whatever remainder that you get is your required remainder. So let's take one example. So here we have taken 31 to the power 32 when divided by 3. What should be the remainder? So as per the rule, 31 I divide by 3 first. So by dividing 31 by 3, let me find the remainder. So the remainder that I get, of course, is 1, because 30 is a multiple of 3. So I remove 30 from that, I get remainder 1. So my R becomes 1. So here, as per the rule, my R here is nothing else but 1. That is why I have mentioned this step here. So the remainder becomes 1. 1 to the power 32 divided by 3, whatever remainder that I get is my required remainder. That is my answer indeed. Okay. So 31, I repeat again, when divided by 3 leaves remainder 1. So 1 per 31. So I am just dividing 31 by 3. Whatever remainder that I get, that remainder to the power 32. So the same power exists. So 1 per 32 gives me 1. 1 divided by 3, of course, 1 is my answer. Got it? So we have, for every rule, this video also carries 2 sample questions. So let's go to the sample question to, again, re-emphasize the concept. So the first practice question, sample question is here. The question says, find the remainder when 29 to the power 29 divided by 3. So here it goes. As per the concept, I have to divide 29 by 3. Whatever remainder that I get, that is my R. So 29 divided by 3, actually, 27. So I will get 2. Okay, so my remainder becomes 2. So what I'm supposed to do? Again, 2 power 29 by 3 is, bit complicated. So I would take my remainder as minus 1 instead of 2, because 30 is the next multiple. So of course 30 minus 1 is 29. So my remainder becomes minus 1. Okay. So when my remainder is minus 1, I just apply the rule. So this becomes minus 1 to the whole power 29 divided by 3. So whatever remainder when I divide minus 1 per 29 by 3. So minus 1 per 29, what would it leave? Of course, the number in the power is an odd number. So of course, I would end up with minus 1, right? So minus 1 is my remainder. So when I have minus 1 as my remainder, yes, you are correct. So the correct remainder, the positive remainder is 3 minus 1. That is my divisor. Minus 1, 3 minus 1, 2 is my remainder. So my answer will be 2. I repeat. So 29, we are actually dividing by 3. Instead of taking 2 as the remainder, we are taking minus 1 as the remainder. So minus 1 per 29 divided by 3 is your required remainder. And minus 1 per 29 gives you minus 1. So 3 minus 1 is your required remainder indeed. Right? I hope this would help you better. So let's get into the next question, next practice question. So the next practice question is 79 to the power 79 when divided by 8. Exactly. So we apply the same concept here. So 79 to the whole power 79 we are going to divide by 8. So what we'll do, so of course here 79 will divide by 8 to find the remainder. My remainder is just again going to be minus 1. So I'm not going to take the positive remainder, instead I'll take the negative remainder because it's a very closest number. Okay, since suppose if my number is 76, it is again you see minus 4. So minus 4 again it's a complicated number, so I won't go with that. Since it is minus 1, it's very easy to calculate. So that is why I'm taking remainder as minus 1. So now I'll take minus 1 to the whole power 79 divided by 8. Whatever remainder that I get, minus 1 to the whole power 79 divided by 8. Now minus 1 to the power 79 gives me minus 1 only. So 8 minus 1, 7 is my answer. Okay, so here it is actually minus 1. So we'll go for the positive remainder. 8 minus 1, 7 will be your answer. The correct answer is 7. Moving to the next rule. Yes. So when it comes to the basic rule 2, the basic rule 2 says that suppose if you have a series of numbers in your multiplication and you have a divisor. So dividing by one divisor. So you need to find the remainder. So we break them and take it in this form. So let's say A into B into C when divided by D, you need to find the remainder. It is not necessary to multiply A, B and C and then divide. Instead, A by D leaves you remainder and that's your remainder 1. Let's say that's your remainder 1. And B by D leaves you remainder 2. And C by D leaves you remainder 3. So now we can just multiply remainder 1, 2 and 3. And if it is definitely greater than the divisor, again, we divide and find the remainder. Else, the product is going to be the remainder as such. Okay. So let us go for a very simple example. I have taken three numbers 30, 31 and 32. So it is not necessary that you have to have only three numbers. You can even take two numbers. It can be 30 into 31 divided by 7 or 30 into 31 into 32 into 33 divided by 7. Any series of multiplication, this rule applies. So when divided by 7, we need to find the remainder. Okay, so 30 divided by 7 leaves remainder 2 and 31 divided by 7 leaves remainder 3 and 32 divided by 7 leaves remainder 4. So it's very easy for us to calculate. So now I'll just multiply 2, 3 and 4 because on multiplying 2, 3 and 4, I'm going to get a number which is definitely greater than 7. So I'll again multiply them and find the remainder when divided by the given divisor. So 2, 3 and 4 product being 24, 24 divided by 7 of course leaves remainder 3 and that's the required remainder. Okay. So I believe the concept is clear. We are again going to solve another practice question to understand the concept better. So this is the practice question number 3 and find the remainder when 233 divided by 411. Okay. So I am going to find the remainder in each case. That is 233 I'll divide by 8 and find the remainder. And again 411 I'll divide by 8 and find the remainder. And you see like 899 I divide by 8 and find the remainder. Let's do that. So my remainder 1 or let's say 233 divided by 8. So let's do it here. So 200 and okay. Yeah, 233 divided by 8. So divided by 8, I'll take 16. So 16, this is going to be 73. Okay, so 73 and again I'll take 72. My remainder is 1. Okay, so this leaves remainder, that is 233 dividing by 8 leaves remainder 1. So let me write the remainder alone here. 411, again 411 on dividing by 8. So sorry, on dividing by 8. So this is 40. We'll get 1 and 11. So 8, your remainder is going to be 3. Okay, so I'll write the remainder separately here. This is 3. Same way 899 on dividing by 8. So let's put it here. 899. 899 on dividing by 8. So this is 8. See here, if you could observe, I am not bothered about the quotient at all because all I focus is only on the remainder. So my remainder is 3. Okay, so I'll write the remainder here, which is 3. Sorry, yeah, this is 3. Okay, so now since it is a multiplication symbol in between, I'll multiply all these remainders. 1 into 3 into 3. 1 into 3 into 3 gives me 9. So 9 divided by 8, whatever remainder I get is the required remainder. So 9 on dividing by 8, of course, as you all know, yes, the remainder is just, yeah, the remainder is just 1, and that's your answer. So the correct answer for this question is 1. The remainder is 1. Let's move into the next slide. So here is a practice question number 4. So here is our practice question number 4. So same thing, like 4,555 on dividing by 11. So I did this calculation on dividing by 11. I got a remainder 1 if I'm not wrong. And 6,777 again gave me a remainder 1. And 8,999 gave me a remainder 6. So I'll multiply 1 into 6 and my answer is 6. So 6 is a number which is less than 11. That is my divisor. So 6 will be my answer, direct answer. Got it? So you can also cross verify. You will get 6 as your remainder for this question. Let's go to the next rule. So here is the basic rule number 3. It is just a replica of your basic rule number 2. The only difference being, so here in the basic rule number 2, we had the multiplication. So we multiplied all the remainders individually and then found the remainder. So here in basic rule number 3, it is the addition symbol in between. So simple. Yes, we will just do the addition and do the same process again. So the question, I mean, we have an example to substantiate the given rule. 300 plus 311 plus 322 divided by 7. So same way, 300 divided by 7 leaves remainder 6 and 311 divided by 7 leaves remainder 3 and 322 divided by 7 leaves remainder 1. So we would just add instead of multiplying. Since it is the addition symbol in between, we would just add the remainders and then divide by 7. So on adding all the remainders, we got 10. 10 divided by 7 leaves remainder 3. Yes, exactly. So next we have another 2 practice questions to re-emphasize the concept again. Let's go for practice question number 5. So 233, if you remember, 233 divided by 8, we got remainder 1. And 411 divided by 8, we got remainder 3. So 899 divided by 8, we got remainder 3. Exactly, we have to add now. It's not the multiplication, it is the addition. So 3 plus 3 is 6, 6 plus 1 is 7. So 7 is a number which is less than 8. So your answer, direct answer is just 7 as such. Okay, the required remainder is 7. Yeah, moving towards the next question. Again, I hope you remember. So the remainder for this is 1. That is 4,555 on divided by 11 left remainder 1. 6,777 again left remainder 1. 8,999 leaves, I mean, this remainder we got is 6. So exactly we do the addition in between. So 6 plus 1, 7, 7 plus 1 is 8, and that's the answer, direct answer. So the remainder when all this divided by, I mean on adding all these numbers and then dividing by 11, the answer, the required remainder being 8. So moving to the next type. So we went through 3 different basic rules. Now we are, we have reached a common factor process. So let us again understand that you have a question when to find the remainder x divided by y. Suppose x and y has a common factor, that is x can be written as k into x and y can be written as k into y, that is k being a common factor. So you take k out and the required remainder is nothing else but k into the result of remainder of x by y. Okay, so again to re-emphasize, we have taken a concept, we have taken an example here. So 4 to the power 15 divided by 28. So 28 can be written as 4 into 7 indeed, and the numerator is 4 to the power 15. So I have a common factor. So I'm going to take 4 outside. So when I take 4 outside, this becomes 4 to the power 14 and this becomes 7. Okay, so 4 into the remainder when you divide 4 to the power 14 by 7. So, if you could literally understand 64 when dividing by 7 leaves remainder 1. Okay, so we are going to focus on 64. 64 is nothing else but 4 to the power 3. Okay, so you can convert this. See, 4 to the power 14 can be written as 4 cube. Okay, 4 cube to the whole power 4, right? So this takes away 12 into 4 square. Okay, so you can write this as 4 cube to the whole power 4 into 4 square. So that is what has been written here. 4 square is 4 into 4 and 4 cube to the whole power 12. 4 cube to the whole power 12 is nothing else but again 64 to the whole power 4. So 64 to the power 4 leaves you remainder 1. So this becomes 1 and this is 4 into 4. Right? So 16 divided by 7 leave you remainder 2. So 2 into 4, 4 that we have already taken. So your required remainder will be 8. Okay, I hope this is clear. So no worries, but we still have 2 more examples to clear out the concept. Let's go for practice question number 7. So here we have 15 to the power 16 divided by 35. Let's put it here. 15 to the power, okay, to the power 16. Okay, yeah, to the power 16 divided by 35, isn't it? So this we can definitely, yes, you're 100% right. So we can take this as, let me put it here, we can take this as 5 into 5 power 15 divided by 5 into 7. Okay, so as per the concept, we'll take 5 out. So 5 into remainder, when you divide 5 to the power 15 divided by 7. So now this is going to be an easy process. So 5 to the power 15 divided by 7, again, we can take it this way. Yeah, 5 to the power 15, we can take it this way. I'm going to take 625 because 5 multiples, 5 powers will be like 5 to the power 1 is 5. Okay, 5 to the power 1 is 5. 5 square is 25. Then I have 125 and 625. Okay, so 25 on dividing by 7, I'll get remainder 4. It's a bigger number. 125 divided by 7, again I'll get remainder 6. So again, that's a big number. So whereas 625 divided by 7 will leave remainder, I guess will leave remainder 2, a lesser number. So it's better that I go with that. Yeah, 625 divided by 7, I think I got remainder 1. So let me just do it that way. So I'll take 5 to the power. Okay, so this I'll write it as, so I'll continue from here. 5 to the power 15, I can write this as 5 to the power 4 to the whole cube. So this will be 12 into 5 to the power 3 into 5 cube divided by 7. I think this step must be clear. Okay. So 625, somehow I have to, combine it to 625. So I'm writing 5 to the power 15 as 5 to the power 4. That gives me 625 to the whole power 3. So this takes away 5 to the power 12. Remaining I have only cube. So 5 cube divided by 7. So 625 to the whole power 3 divided by 7 into 5 cube, that is 125 divided by 7. So both the cases I need to find the remainder. So 625 divided by 7 will give me 2 as my remainder. So yeah, so will give me 2 as my remainder. So 2 to the whole cube. Okay, 2 to the whole cube into 125 divided by 7. So this is what I need to find, 125. So both I'll divide by 7. So 2 cube is nothing else but 8. So I'll continue here. 8 on dividing by 7 will leave remainder 1. And 125 on dividing by 7, I think I'll get remainder 6. So 1 into 6. Yeah, 1 into 6 divided by 7. 1 into 6 is just 6 and that's going to be the required remainder. Let me repeat once again. See, 5 to the power 16 divided by 35, we need to find the remainder. So 35 also has 5 as its factor. So this way you can, convert. Let's put a different color to understand this again. So this is the second step. That is 5 into 5 power 15 divided by 5 into 7. So 5 and 5 will take out common. So 5 into remainder when you divide 5 power 15 by 7. That's the required remainder. Got it? Yeah. So here we forgot multiplying it with 5. Let's do that. So now what we can do is 5 to the power 15 by 7. So this is your challenge. 5 to the power 15 divided by 7. So the powers of 5 are like 5, 25, 125 and 625. So 125 dividing by 7 will leave us remainder 6. So let's not literally touch that, but 625 dividing by 7 leave remainder 2. So it's better that that's a lesser number, so we might as well can go for that. So in order to get 625, we are writing 5 power 15 as 5 to the power 4 whole cube into 5 cube. So 5 to the power 12 into 5 cube, which gives you 5 power 15. So 5 to the power 4 is 625, cube is into 125. 5 cube is 125 divided by 7, both the cases. So this will leave remainder 2. 2 cube is again 8. 8 divided by 7 leaves you remainder 1. And 125 divided by 7 leaves you remainder 6. So 1 into 6 is just 6. I have to multiply this with 5 because here this 5 is still there. So that we have to do. 5 into 6 is 30 and that's the required remainder. Okay. 60 is your required remainder. Sorry, 30 is your required remainder. Let's move to the next question so that you get a bit familiarized. So the next question is here, 8 to the power 12 divided by 24. So I believe practice question number 8 you can solve and give your answers in the chat box. There are a few other questions also for you to give answers, but still practice question number 8 also you can definitely consider. It is the same process. So here let me begin the process so that you can continue and find the answers. So 8 to the power 12, right? So 8 to the power 12 divided by 24, I'm going to write as 8 into 3. Okay, so I can take 8 out. 8 to the power 11 divided by 3. So you need to just find the remainder when 8 to the power 11 divided by 3 and just multiply it with 8 and that's the required remainder. Okay, so you can solve and tell me your answer. So we are moving to the next theorem. It's a very important theorem, Fermat's theorem, to find the remainder for any exponential. So the theorem says the remainder of a to the power p minus 1 by p is 1. On divided by p leaves a remainder 1. The condition being p should be a prime number. That is, your denominator should be a prime number and the HCF of a and p must be 1. That is, a and p must be co-primes. Okay, so let's take one example here. 2 to the power 345 divided by 11. Okay, the first step that I'm going to do, say I cannot directly definitely apply because you see like this is divided by 11 and the power it is 345. So I cannot relate it to p and p minus 1 of course. So I'm going to reconsolidate it. The 345 can be written as 2 power 10 to the whole power 34 divided by 11 into 2 power 5. So this becomes 340 plus 5 is 345. So ultimately we get 345. Okay, so here I can apply this step. So I'm just applying this step in a part of it. So 2 to the power 10, which is a to the power p minus 1 divided by p. Okay, divided by p. So of course I can apply this. So p minus 1 is 10. So I'm going to use this Fermat's theorem. So 2 to the power 10 divided by 11 leaves me remainder 1. So 1 power 34 again leaves me remainder 1 as such. So my remainder in the first case is 1. So 2 to the power 5 is 32. 32 on dividing by 11 I get remainder 10. So 1 into 10. 10 is the required remainder. So in all the cases we are just about to break down the complexity and put it in a simple format. Apply whichever possible and find the answer. So that's the whole solution of it. Let's go for another question again to understand the concept better. So here we have to find the remainder when 377 to the power 4 divided by 5. I think I can directly apply because the rule says that the remainder when you divide a power p minus 1 by p, okay, leaves you 1 and the condition is that p should be a prime number. So 5 is a prime number. See here I'll just put the replica format. 377 to the power 4 divided by 5. Okay, so 5 is a prime number. 5 minus 1 is there. 377, that is A and P should be co-prime. That is 377 and 5 are of course co-prime. So I can directly apply and say that my remainder is 1. Okay, my remainder is 1. Next question. So practice question number 3. Again, this is a direct note answer where 113 to the whole power 12 divided by 13. So you need to find the remainder. Again 13 minus 1, 13 is a prime number, 113 and 13 are co-primes. So your answer will be 1. The correct answer is 1. That is the required remainder is 1. So the next slide, so this slide is going to tell you about your Wilson's theorem. So the Wilson's theorem says that when p minus 1 factorial, okay, so p minus 1 factorial on dividing by p, okay, leaves remainder p minus 1. So this is the remainder. Okay, and same way, let's write it here. P minus 1, sorry, p minus 2 the whole factorial divided by p will leave remainder p minus 1. Okay, so where p should be again a prime number, that's the condition. So again see 40 factorial divided by 41. Of course, it is like, yeah, it's like, 41 minus 1 divided by 41. So you can directly say that for it will leave p minus 1, that is 41 minus 1, 40 as your remainder. Okay, 40 will be a direct. So it's a direct, answer where if you can remember this theorem. So let's move to the next question. Again, the same thing, like 45 factorial. See here, 45 factorial divided by 47. So I can write this as 47 minus 2 factorial divided by 47. So p minus 2 factorial divided by p will leave remainder 1. So that is also a part of your Wilson theorem. So the correct answer is just 1. The remainder is 1. The next question is here. So this is actually one of the challenging question. Okay, so I am just going to do it very slow so that you understand the concept better. Okay, so let's take it here. So 21 factorial divided by 361. So you must be wondering how 21 factorial and 361 I can compare to take this theorem forward. So we can definitely not relate 361 and 21 directly, but with factorial part you can. So 21, I'm going to write this as 21 into 20 into 19 into 18 factorial divided by 361. You must be wondering why I should stop with 18, because 361 is nothing else but 19 into 19. Okay, so 361 is actually 19 into 19. Let us put it this way. So here it is like 21 into 20 into 19 into 18 factorial divided by 19 into 19. So we have a common factor here. So we are applying the common factor theorem. So I'll take 19 outside into remainder. When you divide 21 into 20 into 18 factorial divided by 19. Okay, so again we are going to divide this into another complex form. Okay, so I mean another simpler form. Sorry, so 19 into, when you divide 21 by 19, 21 divided by 19, of course your remainder will be 2. Okay, so remainder when 20 divided by 19 is 1. Remainder when 18 factorial divided by 19. So this applies your theorem. Okay, so 19 minus 1 factorial divided by 19 will give 19 minus 1 as your remainder. So 19 minus 1 is 18 and that's your remainder. Okay, so let's take, we are just supposed to multiply 2 into 18. Again, we need to divide it by 19 and find the remainder of this and then multiply it with 19. So this is going to be the procedure. So 2 into 18 gives us 36. So I'll write this as 19 into remainder when you divide 36 by 19. So 36 divided by 19 will leave us, I think 17, because 38 will be the next multiple. So it should leave 17. So 19 into 17 is your answer. 19 into 17 will be your answer. So let's multiply 19 into 17. We will get, okay, so we'll get 693. So 3 and this will be 2 and 3. So 323 will be your answer. Okay, so the correct answer, that is the remainder when we divide 21 factorial by 361 is 323. Let's again come from the beginning to understand better. I'll put it in a different color. So first thing is that we'll split 21 factorial as 21 into 20 into 19 into 18 factorial. Why we are dividing till 19? Because 361 is a product of 19 and 19. 361 is 19 square. So we have a common factor. We'll apply the common factor rule. So 19 into remainder when you divide 21 into 20 into 18 factorial by 19. Okay, so 21 on dividing by 19 leaves its remainder 2. 20 on dividing by 19 leaves its remainder 1. And 18 factorial on dividing by 19 leaves its remainder 18. So we are applying the previous theorem. So this tells you like 19 minus 1 factorial divided by 19 should leave you 19 minus 1 is your remainder. So 19 minus 1 is 18 and that's your remainder. Okay, so actually now we are supposed to multiply 19 with the remainder when you get to, remainder when you get on multiplying 2 and 18 and dividing by 19. So 2 into 18 gives us 36. 36 divided by 19 leaves us remainder 17. So 19 into 17 is the correct answer. 323 will be the required remainder. I hope all the questions, you are able to relate with any one of the concept and streamline it and, do your calculations accordingly. So this slide gives you practice questions number 13, 14 and 15. I want you all to try these practice questions, apply whichever rule possible to the easiest extent and find the answer. Okay, so please post your answers in the comment box and I would definitely reply you with your corrections. So again, if you have any doubts, you can definitely post it in the comment box indeed. Any question, any particular slide, you can definitely post it in the comment box. I'll revert with a correction video or revert with a doubt clarification part. Thank you so much for watching. All the best.